Now we will see the supernode analysis. When there is a one voltage source which is present between the two nodes, then these two nodes will be converted into a supernode. So there are two conditions during applying the supernode analysis. Suppose there is a node 1 and this is node 2 having the voltage V1 and V2, and between this one voltage source is present. Suppose it is 2 volt, and we are considering the direction of the current is like this. Then we have to find the equation for this supernode will be like this. We know the initial voltage minus final voltage divided by the resistance is a main equation, but in that all these three are the voltage sources. So simply, suppose I am going from this terminal to this terminal, so simply it is V1 starting terminal or starting voltage is V1 minus, see here the current which is flowing from plus to minus terminal, so it is negative or falling voltage, so minus 2 minus V2 which is equal to 0 because it is initial minus final. So simply V1 minus V2 which is equal to 2. This is the equation for this supernode. And if the voltage which is present between the two nodes having the opposite terminals, suppose it is negative and the plus, and we are going like this, then simply it is initial voltage V1, then see here the current which is flowing from minus to plus terminal, so it is rise in voltage, and I am considering it is plus 4 minus final voltage is equal to 0. So simply V1 minus V2 is equal to minus 4. So this is the equations for the supernode. Now we will consider one equation or one problem. Find the current through the 4 ohm resistor. We have to find the current through this 4 ohm resistor. All the steps which we have used in the nodal analysis, these are the same here, but here we are considering the supernode. For one supernode we are considering the two equations. That means for this equation, and we are applying the KCL at different nodes. So simply first step is we have to consider the nodes, but here the nodes are given, it is V1 and V2, and then we have to consider the actual direction of the current. So simply 5 ampere is the current source and the direction of the current source is given. So it is, suppose this is the I1, then this current I1 is coming here distributed in 2, suppose it is I2. Then we are not considering the current for the supernode. Then the direction of the 2 ampere current source is also given, so it is like this. Suppose it is I3, and I am considering the current which is going away from the node 2 and through the 4 ohm resistor is I4. Now we have to first apply, or we have to find the equation for the supernode first. So simply for this supernode which is having the voltage 6 volt between the V1 and V2, we get the equation like this. For the supernode, it is V1 minus V2 which is equal to 6, as you have seen in the first case. This is the equation for the supernode. First step is apply KCL to supernode 1 and 2. So simply it is V1 minus V2 which is equal to 6. Suppose this is first equation. Then we have to apply the KCL at the supernode. Simply 1 and 2. This is the final equation which is voltage in between the two nodes. But now we are applying the KCL at for the currents, different currents. So simply see here I1 current which is coming to the node, so therefore I am considering it is positive, because we are considering the incoming current is positive and the outgoing current is negative. So simply I1 is the incoming current, therefore it is plus I1, then I2 is the outgoing current, so it is minus I2, and here I3 again is the incoming current, so simply it is plus I3, and I4 is the outgoing current, so simply it is minus I4 which is equal to 0. So simply we are finding the equation for the I1, or I1 is directly given, it is 5 ampere, so therefore it is 5 minus I2. See here we are considering it is the reference voltage VC which is equal to 0 volt, because which is connected to the ground terminal. Then we know we are finding the current like this, initial voltage minus final voltage divided by the resistance. So for I2 it is V1 minus 0, because 0 is the reference voltage, divided by 2 ohm resistor. So initial minus final voltage divided by the resistor, it is the current I2. Then we are finding for the current I3, or it is I3 is directly given, it is 2 ampere. So simply it is 2 minus I4. I4 is, see here, I4 which is flowing from V2 or terminal 2 to the reference node. That means initial voltage is V2 and the final voltage is Vc, which is equal to 0 volt. So simply it is V2 minus 0 divided by 4. So simply I4 is 0, which is equal to V2 minus 0 divided by 4 is equal to 0. Then by solving this we get the equation will be like this. It is 0.5 V1 plus 0.25 V2, which is equal to 7. Suppose this is second equation, and by the first and the second equation solving in the scientific calculator, we get the values of V1 and the V2 will be like this. V1 is equal to 11.33 volt and V2 is equal to 5.33 volt. But the question is, we have to find the current through 4 ohm resistor. That means current through 4 ohm resistor, and here we have considered the current through 4 ohm resistor is I4. So therefore current through a 4 ohm resistor, which is equal to, simply it is initial voltage minus final voltage divided by the resistance, or simply it is V2 divided by 4, or simply V2 minus 0, because 0 is the reference voltage. V2 minus 0 divided by 4, which is equal to V2, we know V2 have find it here, it is 5.33. so simply it is 5.33 divided by 4, and which is equal to 1.33 ampere. This is the final answer. So through the 4 ohm resistor, current is 1.33 ampere is flowing. Thank you. The second problem, which is based on the supernode analysis, is we have to find the current through a 4 ohm resistor, that means through this 4 ohm resistor. The first step is we have to consider the different supernodes or different nodes, but here in that circuit the nodes are given, it is V1, V2 and the V3, and the next step is we have to consider the different direction of the current. Suppose this is a 5 amperes current source and having the direction which is in the upward direction, we are not changing that direction, so simply it is I1. Then current through a 2 ohm resistor will be I2, and current through a 5 ohm resistor is I3. For this current source, direction is given, therefore we are not changing it. When considering the direction through the 4 ohm like this, it is I5, and we have to find this current I5. Now next step in the supernode analysis is we are applying the, or we are finding the equation for the supernode first. So simply, as we have seen in the first equation, the different conditions or different two conditions for the supernode. So simply here it is V1 minus V3 is equal to 8. This is the first equation. V1 minus V3 is equal to 8. Now we are applying the KCL at the supernode by considering the currents at the supernode. So simply it is, see here, at node V1, I1 current is flowing. We are not considering the current through a supernode. Okay. Now at node V1, the current I1 is coming. So simply it is plus I1, and we are considering the incoming current is positive and the outgoing current is negative. So simply I1 is plus, I2 is the outgoing current, so simply it is minus I2. Then at this node we are not using, or we are not applying the KCL at node V2, because V2 is not at the supernode. We are finding first the equation for the supernode. If there is one supernode, in that case there is a two equation for the supernode, like this, simply in terms of the V1 and simply in terms of the current. So here now we are not applying the KCL at node V2, we are simply considering the node V1 and the V3. So simply I1 is the plus, I2 is minus. Then at node V3 again I4, which is the 8 ampere source, which is going away from the node, and we are considering it is minus I4. Again I5 is going away from the node, so simply it is minus I5, which is equal to 0. Then we are finding the different currents. Simply I1 is given, it is simply 5 ampere, so simply 5 ampere. Then minus I2 is simply flowing from V1 to V2. So simply it is initial voltage minus final voltage divided by the resistance. So simply it is V1 minus V2 divided by 2, then minus I2. Okay, this is the I2 current. Then we have to find I4. See here, I4 is given, it is 8 ampere. So simply directly it is 8 ampere minus I5. I5, see here, this is the current flowing from V3 to the reference voltage, and we know the reference voltage having the 0 volt. So simply it is V3 minus 0 divided by 4, or simply it is V3 divided by 4. So minus it is V3 divided by 4, which is equal to 0. And by solving this equation, we get the final equation like this. It is 0.5 V1 minus 0.5 V2 plus 0.25 V3, which is equal to minus 3. Suppose this is second equation. Now we are finding the equation for the another node which is not coming under the supernode. So simply it is V2. Now apply, or we are applying KCL at node 2. So see here the incoming current is I2, outgoing current, incoming current are I2 and the I4, and the outgoing current is I3. So simply incoming current we are considering is plus, minus I3 plus I4, which is equal to 0. Then equation for the I2 is V1 minus V2 divided by 2. V1 minus V2 divided by 2 minus I3. I3 is having equation V2 divided by 5, or simply V2 minus reference voltage is 0. So V2 minus 0 divided by 5, or simply V2 divided by 5. Simply it is V2 divided by 5 plus I4. I4 is given, it is 8, which is equal to 0. And by solving this, we get final equation is like this: minus 0.5 V1 plus 0.7 V2, which is equal to 8. Suppose this is third equation, and by solving these three equations 1, 2 and 3 in the scientific calculator, we get the values of V1, V2 and V3. So simply by solving this equation, V1, which is equal to 12 volt, V2 is equal to 20 volt, and V3 is equal to 4 volt. Now the main question is we have to find the current through a 4 ohm resistor, that means through this 4 ohm resistor. So simply through the 4 ohm resistor we have considered the current is I5. So simply current through a 4 ohm resistor is equal to I5 is equal to V3 divided by 4. So simply it is V3 divided by 4, and we know the value of V3, which is equal to 4. 4 divided by 4, which is equal to 1 ampere. That means current through a 4 ohm resistor is equal to 1 ampere. This is the final answer. Thank you.